Friedel-Crafts acylation explained thoroughly. This is a fundamental example of an electrophilic substitution mechanism. Okay, the two examples I'm going to go through today are the reactions of acyl chlorides in benzene and the reactions of acid anhydrides in benzene. Okay, so why is benzene so reactive? It has a delocalized ring of electrons, which is extremely rich in electron density. This means it's prone to attack by electrophiles, which are electron pair acceptors. In this case, the electrophile is basically an acylium ion. Okay, so how does this work? Let's assume that we have ethanol chloride, okay? We're going to react it with aluminium chloride to form the electrophile, because without an electrophile, there is no electrophilic substitution mechanism. Okay, we react it with AlCl3, then we form AlCl4, and we form the electrophile, CH3CO. Okay, with a delta positive carbon. What happens now? You draw an arrow from the delta negative benzene ring to the delta positive carbon. Okay, now you draw the fact that this acylium ion has now been attached alongside a hydrogen that was already attached prior to the acylium ion being attached. Okay, then you draw a horseshoe in the direction of these two chemical entities and an arrow going from the bond to the hydrogen to the horseshoe. This shows that a proton has been lost. Then to reform the catalyst, you show that AlCl4- is reacting with the H+ to form AlCl3 and HCl, which is a toxic and corrosive gas. What happens when you react an acid anhydride with benzene? So let's say you have ethanoic anhydride. So what do? Essentially, the mechanism is exactly the same. It's congruent. However, reforming the catalyst and forming the electrophile is fundamentally different. So I've circled what you need out of the ethanoic anhydride and what you don't need. Essentially, you can think of it like this. You react it with aluminium chloride, then you form, essentially, what you don't need, plus the AlCl3 on the bottom, and then alongside this you form the electrophile. So when you reform the catalyst, it will be H plus this intermediate, which is an ester pretty much, and then you form essentially ethanoic acid and you form the AlCl3 again. So ladies and gentlemen, that is essentially Friedel-Crafts acylation in a nutshell.